Hello everyone. The topic that I am going to discuss today is set interface. Now this topic is part of the subject called Advanced Java Programming, and the first thing that I want to say you is I want to introduce myself. My name is Shomshubra Shaha. I work as an assistant professor in RMK College of Engineering and Technology in Chennai. So let's begin. Okay, before entering into the main topic, what is set interface? First, we have to know what is interface. Interface is basically defined as a reference style which is similar to the class but used in defining abstract method. That means it is a blueprint for a class. Now, the second is that the interface also supports abstraction because they actually don't have method implementation by default. That means to implement any particular interface, we need classes that will fall under that particular interfaces. Now, interfaces are also used for multiple inheritance. That means basically Java, this programming language, does not suppose multiple inheritance with classes, but a class can implement multiple interfaces, and only constant and abstract methods are only used in case of interface. Okay, let's see what is set interface. Set interface is basically an unordered collection. That means whatever elements are inserted in the set interface, there is no particular sequence maintained for storing or retrieving those elements. And the second point is it is useful for checking presence or uniqueness. Since the set interface particularly this set method do not allow any duplicate elements, or do not allow any other elements which where the same type of elements is already entered into that particular set interface. That is why it is very easy for this interface to maintain the uniqueness or checking the presence of a particular element. And it also allows null value, and it does not support indexing. That means suppose if I want to retrieve a particular value from this set interface, so if I give the index number particular to retrieve that particular value, it is not necessary that I will get that particular value according to that index number only, because whenever it is stored in unorganized manner. And this set technique is taken from this mathematical set operations, where different types of functions we have already learned in our schools, like union, intersection. These all types of functions where we have learned how to use it, and this set interface exactly work in that particular manner only. So as I have already told you in the second slide of this PPT, that what is interface. Basically interface is it will say what type of functions we have to do, or it will instruct what type of functions to do, but it will not tell how to do that particular function. To do that particular function, we need classes under that particular interface. So under the set interface, there are three types of classes. First one is hash set, second one is tree set, third one is linked hash set. Now hash set is related to hash table, tree set is related to binary tree or self-balanced tree, and third one is linked hash set, which is a combination of linked list as well as hash table. Now let's see what this hash set is. The hash set is basically backed by hash table, and the rule of the hash table is that there should be no order, or the set interface itself has no guaranteed or sequence of storing elements in an ordered way. So that is why the in hash table, in case of hash set class, whenever we have to retrieve any of the data from the table, it always gives that those particular data which is nearest to the table. Okay, and it is not maintained, the order is not maintained, not in a sorted manner we will get the output. And it also allows null element. The performance in case of hash set, the performance is basically very fast because it does not maintain any particular order. So whenever wherever position it gets in the heap memory, it's stored there only. So for those things, the add, remove, contain, these type of basic operations are very fast in hash set. So this is the syntax for the hash set. First we have to write the interface name, that is set. After that, whatever data type we are using in the program, so if it is an integer, then the first letter of that particular data type will be in caps. If I am using integer, then I will be in caps. If I am using string, then S will be in caps. And then set name, any name one can give to in this set name place. And then we have to create an object which is new. Then we will give the particular class or implementation which will fall under that particular interface. So let's see the algorithm how to write a program. First step is we will start writing, then we will import packages. So in set interface it falls under java.util package. So we have to write java.util package over here. Then we will write public class, any class name, whatever we feel right. And then we will use the void main function. After that, whatever interface we are using over here, we will create the interface, then the operation, then printing, then this is how the algorithm ends. There are there are 8 steps to write any program related to this particular interface. So let's see the program. First we have to import package. So over here I have taken java.util package. Then I have created a class whose name is xyz. After that, main function has been started. So under that main function, the first step is I have created a set interface. So over there, first is the name of the interface, which is set with capital S. Then I have used the data type, which is string with capital S. And then again I have taken a set name. So this is also with capital S, but if someone wants with starting with small letter, then it is also valid. Then after that equals to, after that I have created an object new. After that I have written the class name which will fall under this particular interface. This is hash set. Then I am adding using this add method, I am adding the first letter A. After that I am also adding another letter B, and then I am printing. So this is the output of the program of the this is first it is printing A, then it is printing B. So let's see, the next is linked hash set. Now the linked hash set is that, first of all, the difference over here is that in hash set, whenever an element is added, there is no order maintained, but over here in linked hash set, insertion order is maintained. Duplicate elements are not there because it is the property of the set interface only that no duplication is allowed. And this linked hash set is the combination of hash table plus linked list, and it is very easy for iteration or predictable iteration. It is very easy to perform over here, and it only, the linked hash set only allows one null element. And in case if someone adds a particular element which is pre-existing, that means if someone adds two elements which is of similar type, it will not show any error. In case of execution of the program, it will not show any error. It will simply give the output, and but the duplicate element is basically ignored in this case, and but it will not show any of the exception or anything like that. So basically this is the syntax of the linked hash set, which is similar to hash set only. Over here, the first we have to take this name of the interface, which is set with S capital, then data type with the first letter of the data type in capital, then any of the set name. It can be in capital or it can be in small. After that, we are creating an object named new. Then we are using the class which will fall under this particular interface. So this algorithm is also similar to the hash set algorithm. First we have to import packages, then we have to write the public class name, then void function. After that we will create the interface, and then we will write the basic operation print, and then the end of the execution. So this is the program where the first I have import the packages like java.util. Then I have taken the public class where the name is xyz, and then a main function is being started. After that I have created the set interface linked hash set using the linked hash set class, where I have given the name of the set as ABC. Then I am implementing add method, that is abc.add. This is how we have to write the command to add any element into the set, and then I am printing. So this is the output A and B. So this is next one is the tree set. In case of tree set class, what happens whenever an element is given, it will store according to a sorted order. That means if the first element is big and the next element is small, then it will give that according to the ascending order only it will store. That is the rule of the tree. So there is no duplication allowed, and it also do not allow null value also not allowed over here. And it maintains this sorted and unique elements. These are all maintained in case of tree set. So this is the syntax, which is also similar to the linked hash set or hash set. So over here, first the interface name, then the data type with the first letter of the data type in capital, then set name, then again creating an object new. After that, the tree set we are using. Over here you can see in every slide also you can see the syntax. The first letter of the syntax first letter of the class name is in capital, and whenever the word set is starting over there, S is also in capital. So this is the syntax basically. So this is the algorithm where first we have to write the package, then public class name, then void main function. After that we will create the interface, and then we will write the basic operation, then print, and then end of the program. So this is the program where we are importing the function the packages first. After that public class name, then void main function. After that I am naming the set name as shom. So we are applying add method where shom.add a, shom.add b, and then printing the result. So this is the output, that is A and B. So now see the comparison between these three classes. First one is the order of element. So for hash set there is no order, and for linked hash set there is insertion order is being maintained, and tree set it maintains the sorted order. Since both the three classes are under the set interface, and set interface does not allow duplication of elements, so no one allows any duplication over here. Then the null element, for hash set it is 1, for linked hash set is also 1, but in case of tree set it only allows null if the set is empty. That is the condition for tree set. Next is the performance. Hash set is the fastest, linked hash set little bit slower than hash set, and but the tree set is slowest. So what is the underlying data structure? For the hash set, the underlying data structure is hash table. For linked hash set, it is, as I have already told you, that it is a combination for hash table and linked list. The third one is tree set. Tree set means actually the underlying structure over here is red black tree, which is a self-balancing binary search tree. So up to here is only today's lecture. So thank you for listening to my lecture. If you have anything to ask, then you may ask. Thank you.